Hello ladies and gentlemen, my name is Decryption and I hope you are well. In my last relationships tutorial, we created the updated relationship base, where we can see what Bob over there feels about us, we can make him like us, love us, we can make him hate us, and then we can add conditions and stuff to check whatever we need. That was just a basic framework. In this next tutorial, we're going to look at adding a buff system. This is very common in games like where the factions hate you, so like Skyrim or Fable, where if you get married or if you hurt somebody, you'll have a buff and they'll dislike you for a period of time. And we're going to add that into our game with some expansions to make it even more flexible. So let's get started. I am going to start this video by saying I actually have already recorded all of this. It was about an hour and a half long. Okay, and it worked, but it was only okay. I wasn't a huge fan of the system. It worked, it was just not great. It was fiddly, it was going to be prone to bugs if you had anything over 7 days, if a buff lasted 2 weeks, for example. So it wasn't great. So I've actually deleted it and removed it all. And I've rebuilt the relationship system exactly to the point where we were on the last video. But now we're going to do the buff system again, but even better than it was before. You have no context of that because you've not seen it, but trust me, it's going to be a lot nicer. So one of the first things I'm going to fix is something that I was meant to add into the last video, but I never did, is on the update relationship, we're never clamping the value, which means we can technically have a relationship of over 100 or below minus 100, which is not what we want. So for example, if I come in here and I rename the guy to Nice Merchant so it fits in, if I get his relationship, it's currently 0, but if I advance it by 120, it goes to 120, but that's out of bounds for what I want my relationship system to be. I'm sure loads of you spotted that last time, but yeah, we'll just quickly fix that. So I'm coming back into my game instance, update relationship. On the completed, I'm simply going to get the value, I'm going to clamp it with an integer, and then I'm going to promote this to a local variable, updated value. Tick that on completed, and I'll stick it on the add here. If you don't know what a clamp does, it literally does what it says. It sets a value between something. So if it's below minus 100, it will clamp it to minus 100. So you could set this to a minus 1,000,000, and it will ignore all of that and set it to minus 100. If it's over 100, it will clamp it to 100. Really useful node. There's also a ton of other clamps you can use that are all really useful. Vectors, axis, integers, there's floats in here, there's all sorts. And then down here, instead of passing it into both of these, I'm just going to overwrite it with the updated value. And if you didn't know, you can replace a variable that's the same data type. If you just drag on top of it like that, it'll replace it. I'm also going to copy this and just do the same thing over here, where we are updating the relationship. So we add the value to the value we're passing in. We don't need this one, so we're going to clamp it. And then instead of using the variable, we're going to attach it back up there. So all this means now is we should never be able to go above or below a minus 100 and 100. The variable down here is literally just because we use it in 2 places here. So if we just give it a quick test just to make sure it works, 120, we're capped at 100. It doesn't matter how far we go, it will never be over 100, which is perfect. So what is a buff system? Let's jump into this then. So for example, say this guy here who's now called Nice Merchant, so I'll call him KM. He's my dad. He's not, but he's my dad. Always going to have a love for me because he is a blood relative. Same as my mother, my sister, my family, stuff like that. So no matter what you do, they're always going to kind of be a bit lenient to you, in my game at least. So a buff system on this case would be he has a buff with my relationship because we're blood relatives, and I'll set it to say it's always adding on plus 50 because he's a family. So it doesn't matter if I go around and kill the entire town, he will hate me, but he won't hate me that much. Because if I killed everybody in the town, it would be minus 100, everybody hates you. But he will be minus 50 because you're blood relatives. That's what type of system I'm going for. Equally, If this wasn't my father, and instead it was Grog the beer, hates me, absolutely despises me, because I killed his family. Sure, it was a bandit quest or something. He has a buff on there of killed relative, meaning I killed one of his family members, and it'll be set to -50, meaning he will, no matter what I do, I could save everything in the world for him, but because I killed his relative, he will just always have that buff of -50. That's the type of system I'm going for, because it can really add to the game and make it flexible, and it holds you responsible for your choices. It's not like some games where you go around, you murder an entire village, and the person's like, I hate you. You give them a bunch of roses and they're like, let's get married. Not in this game. If you do that and the buff is applied, they will never get to that state because they cannot. So you could give them all the roses in the world, but since they'll have -50 because you kill the relative, they will never, ever truly trust you for it. But the system is flexible enough that you could make it change that. Maybe if you give them roses, it goes up. But if you give them roses infused with diamond oil or something, it removes the buff. There's all sorts of stuff we can do like that. But that's why the system's so flexible in the new version. Enough talking. Let's jump into it. What do we need? Well, the first thing we need is an enum to track the type of buff. So this is blood relative, killed relative, attacked, married, divorced, all the other types of buffs you're going to have. So in my enums folder, I'm going to create a new folder called relationships. And inside here, I'll add a new blueprint enum called E_relationship buffs. And I'll open it up. I'm going to add a bunch to it because I know that's what I need. And I'm going to start adding the buffs that I want in my game. You can, of course, expand this going forwards. It's dead easy. So I'm going to put stolen from. And this is literally, they've caught you stealing from them. Then blood relative, this is the family one. And then you could have some funky quest where you become unofficially blood relatives by, doing that cutting hand thing we used to do. Killed relative, this is you've killed someone close to them. Attacked is you've just randomly attacked them. So the attacked one is definitely one we can put on temporary. So you run up to a person, you punch them, you run away. They've got a buff that you attack them. It lasts 3 days. After that, they don't care anymore. They've got over it. Married is you've found a lover and you've married them, so they're always going to have an appeal towards you. And then divorced, I don't know if I'm going to put this in the game, but it sounds funky, is in you got married and then left. So they'll always kind of despise you for leaving. But they're the ones I'm going to put in my game. You can, of course, put hundreds. I do advise you put as many as you want in to make your game feel good. For now, these are the basic ones I'm putting in mine. I absolutely can add to it eventually, where I've got a whole storyline coming up in my game where you commit genocide against an entire race in the game. That will be on here. It'll be a buff where all of those elves will hate you. So there we go. So we've got our e-relationship buffs. Now we need a way to add this into the relationship here. But because the buffs have special properties like the time, whether it's permanent, the type, we're actually going to create another structure for this. So I'm going to click on this one and press Ctrl B to open it up. And I'm going to add a new blueprint structure called BS_relationship. And I'm going to open it up. So I'll set my buff type here. And this will be my E relationship buffs. Then I'll set a value. And this is going to be the value that it changes it by. So if you've, for example, got... So this will be the -50 to 50 if you're a family. And I'll set that to an integer. You could also, if you wanted to, add a clamped range here. So, for example, if you were family, you could say whatever the relationship is, it's clamped to 50 instead of adding 50. If you want to go that route instead, you might want to. So no matter what you do, there'll always be at least 50 if they're over. I'm just going to stick with adding and removing it for now because that works for me. But I am going to open it up and I'm going to set the value ranges here, just like we did last time. So it lets us clamp down what our values are. There we go. So I can only ever set that. I'll then add a isPerma bool. So I'll do B for bool isPerma, and I'll set this to a boolean. This is if it's a permanent trait. If you kill a family member, that's permanent. That's not expiring. And next is one of the key reasons that I've redone this video, is entirely for the expiry date. In the last video, we were using the float to drive it based on ultra dynamic skies time. So you'll see if I play the game at the top, I have a time ticking down here. And this is Ultra Dynamic Sky's live time. To follow this, you do kind of need some time system in your game. Whether this is Ultra Dynamic Sky or like Narrative Pro and you've got the time system in that. Or if you set up a timer that runs every second ticking a value for 2400, something like that. You need some sort of in-game time. But the key thing here is Ultra Dynamic Sky does have a time of day. But if you break into it more and start looking at it, it actually has a whole time and day system as well. So you can see there's a get date time function here, and this literally returns the year, the month, the day, and the time in your game. So you can get pinpoint accuracy for everything you need. And this is a key thing for our game. If you go to a village and set off a bomb, 100 people see it, they all negatively buff against you, and say you want it to last 5 days in game, perfect. But you don't want to set up 100 timers for each person ticking until it disappears. You could of course set up a group event where it groups all the NPCs together, it ticks one timer and removes them all, but that's still a timer. If you go around and do this to hundreds of villagers, that's still hundreds of timers, even though it's different groups. So instead of setting the expiry date and we checking every 10 seconds if it's passed, and instead of checking every single buff if it's passed or not, what we're going to do instead is set when the buff expires as soon as we create it, and then we will set a single timer running to check all buffs at once when they've expired, which is going to work really, really efficiently. So you could add thousands of buffs in your game at once. You throw a nuke at an entire village, everybody sees it, every town hates you, but it will still only tick one timer for every single person. Super efficient. So this expiry date, I'm going to set to a date time, which is built into Unreal. And if I go to default values, you can see we can literally set the time and day and year and stuff like that. So now I'm going to jump back into my S relationship, and I'm going to add in here buffs. And this is going to be our S relationship buff, and it's going to be an array. And this is going to store all the buffs between these two characters. I am also going to add another variable called final value here, and I'll set it to an integer. And what this is going to do is the value will be the base relationship between your two characters. So character 1 and character 2, you've done some quests for them, they're 50, they like you a lot. But then the buffs will take a hold, and you've decimated their entire village, so they actually hate you, and that will affect the value. But then when the buffs expire, we need to know what to set that value back to. And that's where the final value is going to come in. So the value will be the pure relationship between the two characters. So you can see this in some fancy UI that we might create later. However, the final value will be the value plus all of the buffs added to it. So what's actually going to be used in the game. It gives you a great way of determining which way it is. And if you go through and somehow manage to fix all the buffs, you can just set the final value back to value. You don't need to do any mass calculations running through every buffs, all that other stuff. It's just there, nice and easy. It also means the buffs can stack if you really want it to work that way. So you can have, you killed my family member, you killed my family member, you killed my family member, and that takes 150 off your value. You don't have to go through and remove 50 for each one, you just do the value. It's so much easier. So let's now jump back into our game instance here. And the first thing we're going to do is change the update relationship function. So I'm going to select the function. So when we call update relationship, we are literally changing what the value of the relationship is. So we're going to modify this to also pass in the buffs that we need to add. Equally, you may have the ability to remove buffs. So say you have some armor that removes buffs. We're going to also add it in here to say add these buffs, remove these buff types because we don't need them anymore. So I'm going to come to my BPI game instance. I'll select my update relationship. I'm going to come and add an input, buffs to add, and I'll set this to our S relationship buffs. And then I will add another one, types to remove, and I'm going to set this to our E relationship. The reason I'm doing the enum and the struct for the add is that the struct will have all the properties of how you're setting the buff up. So it'll be how long do you want it to last, what type is it a permanent buff, stuff like that. Whereas the removals, we're saying remove anything where you've stolen from them, for example. So say you get pardoned by the king, suddenly everybody loses the you've stolen buff because you've been exonerated of it. If you wanted to get into the nitty-gritty of removing specific buffs, not the expiry, this is different to the expiry. Say if you had some armor that removed only one stolen one, you could add the S into it, but it's going to be a lot easier if instead you add some type of unique ID into here so you can remove that specific type. Because you don't want to be passing in the value, the buff type, the expiry date of the exact same buff that you passed in at the start. That's going to get really messy. So if you need the ability to remove singular buffs, even if they're stacked, add some type of GUID into here. It's a data type, and then just remove it based on that instead. It'll be a lot simpler. I'm just happy with those two. But I am also going to come to the outputs and add our new final value into it. So I'll call it new relationship final, and I'll just set this to an integer. So that'll be the one with the buff. I am, of course, going to come and do the same thing to the get relationship for the final value. So it'll be relationship final, and it'll be an integer. And I'll hit compile and save. And I'll make sure to set the buffs to add to an array as well, so we can pass multiple buffs. And I'll also do the same for buffs to remove, so we can remove all of these buffs all at once or none at all. Now that we've printed out the final ones, let's just quickly jump back into the cheat manager that we set up to debug this last time. And char1 and char2 are now at value, and I'll put with buffs, and I'll put value, and I'll put buff value, make some space, and now we can connect the new relationship into there. I'll do the same for get relationship, where we come in, they are now at value, and I'll put with buffs, buff value, make some space, and we can connect it across like so. So now we can print out the value with buffs and without. Now let's get into coding our system. So the first part of our code finds if we can find the relationship, and then it updates it based on the value here. However, we at this point, before it sets the relationship, need to tell it, here's the buffs calculated version. So I'm going to come and add a function up here, and I'll call it calculate relationship value. And I'm going to pass in two arguments to it. The first one being the base relationship value, which will be an integer. And the second will be the buffs that we need to consider. And I'll set this to our relationship buffs, and it'll be an array. This will return the new relationship value, which we've calculated after all the buffs, so it'll be an integer. Disconnect that for now. So I'm going to store the value as a local variable called current value, because we're going to keep adding buff entries onto it. And then I'm going to come and loop over our buffs, break this. I will get the value and add it onto the current value. So I'll get the value, I'll add the value to it, and then I'll reset the current value. So it'll get whatever the current value is, add the buff onto it, and reset it. Now you might be thinking, what if I pass negatives into that? Do I need a whole different system? No, you don't. So if I come to a calculator, just to show it off, if I have a relationship value of 50, and I add on to it 50, it will go to 100. That's exactly right. However, if I have a relationship value of 50, and I add on to it minus 50, it will actually take 50 off of it, because that's how it works. And equally, if I'm in negative 50 and I add 50, it will cancel it out. If I'm on negative 50 and I add negative 50, it will go to minus 100. So we can use one single node to do all operations we need to it, because we're only doing subtract and addition. If you're getting into the whole, this buff multiplies your current relationship, whatever, you'll need to look into a more specific option. But that could just be the case if you branch off here and say, do you need to multiply? And do it. After we've done this and we've looped over all the buffs, we can simply come down here and return current value. Now the best part about this function is it doesn't really matter if you pass in buffs or not. If you pass in buffs, it will calculate it and return it. If you don't pass in any buffs, it will go straight to the completed and just return the value you passed. So to make this one nicer, I'll highlight calculate relationship value. I'll mark it as a pure function because we don't need to connect it specifically that way. And then I can come back to update relationship. So down here, it adds the value we've passed in and our current value and adds them together. Just in between here, I'm going to add in our new calculate relationship value, plug in the value that we've calculated, clamp it down just because it's safer, and then all we need to do is pass in our buffs, which we have right here. Now you might be thinking, but decryption, we added in the final value. You are correct. So we will come to the set members here, tick final value. We will add the clamped buff value into it there, and then we will copy the clamp and paste it above just in case on the value, which will go straight to the plus here. The top one will only add them two together and clamp it and run it. The bottom one will add them two together, apply the buffs, clamp it, set it as the final value. So now that we've done that, we need a way to add the buffs into the structure. And this includes calculating how long the buff lasts, so we can get the current time and say you expire in 5 days kind. So what I'm going to do is just come straight up and create a new function, update relationship buffs. And this is different to update relationship. This is like a sub branch of it, which will only handle buffs. We will pass in the current relationship struct. So I'll say relationship, and it'll be our S relationship. I'll also add in the buffs to add array that we added in to the update relationship. So this will be our S relationship buffs, and it'll be an array. And I'll also do the same thing for the buffs to remove, and this will be our E relationship buffs, or whichever way you're handling your removals if you're going the other way. So, depending on how you want your buff system to work with the removals, it could be that you want it to remove existing buffs and then apply the addition ones. If that's the case you want to do it, remove all of the ones first and then add to it afterwards. However, I'm going to treat my buffs differently, as in it will remove any type of buffs. It's first priority. If you're wearing a helmet with the ability of people can never be mad at you for stealing, you've got a jester's hat, people just laugh at you, you want it to apply all the buffs and then remove the ones, even if it's only just added it because you've got the special ability. That's the way I want my system to work. That may not be the way you want to, and this is where you can change it. For me, first, what I'm going to do is promote. So for me, I'm going to loop over all the buffs to add, and I'll do for each loop. And then I'll break on the array element. The first thing I'll do is just check if it's permanent, because if it's permanent, we don't need to calculate an expiry date, so we can just straight add this to say we want to add this buff. So I'm going to drag the array element and just do promote to local variable, and then I'm going to delete that. And the reason we've done that is it's set up all our variable down here for us, and I'll call it buffs pending, and I'll set this to an array by just right clicking on it, and then I can drag this back out and do add. So if it's permanent, I'm just going to straight away tell it, add this buff, straight away. However, if it's false, then we need to calculate how long we think this buff is going to. Now, when we're adding the buffs to our system, we could technically come in and try to set a date here. But I think that's personally going to be a little bit messy, because then we're going to have to figure out from this 00101 time, how long is 3 days kind of thing. So we could come in and say, oh, it's that one there. But it's not intuitive, it's not easy. So what I'm actually going to do is add a temporary variable into this relationship buffs, expiry time length, and this is going to be an integer. The sole purpose of this one is for us to come in and set our buffs up here. This will store how when it's going to expire. However, this one will be, I want it to last 1 day. So 2,400, that's 1 full day. Or I could come in and say 2,400 times 3, it will last 3 days. In your game, you may want someone to be mad at you for 2 hours, so you can put 200. It's really flexible that way. And then now that we've added that to our struct, back in our game instance, on our update relationship buffs, we now have the expiry time length, which means we can take that and add it onto the current time. So, in my time system at least, I'm going to get ultra dynamic sky, which is a function here built in. And then I can drag off UDS and do get, and it's a function there which gets us the current date time of our game. I'll connect that to the false, and then I will drag off this current date time and do plus time span, and then I'm going to drag off of expiry time length, which is going to be our minutes in Ultra Dynamic Sky's language or whatever time system you're using. Time span from minutes. A time span is basically an unreal date time but it builds it up based on a specific time you've given it. I'll connect our integer to the float here. You could use an integer for the minutes if you wanted to say half a second. I don't need that level of precision in my game, so I'll just stick with an expiry time of an integer, 1 minute to 2,400 minutes, and I'll just let it convert it there. But now we can get the date time, add on our time span to it, and that gives us our new expiry time for this function. So I'll make some space back here. So I'll grab this add down here, and I'll just paste it here because it's now a pending buff. I'll connect it up. However, I'm going to make some space up here, and I'm actually going to promote this to a local variable called current buff. And the reason we're doing this is it means we can now set the members instead of having to deal with awkwardly assigning every value. And I can also clean up the code a little, like so. And then down here, I can simply drag the current buff in. I can do set members, and I can tick our expiry time, because that's the one we care about. Plug it in. I can connect it to there, connect it up to there, and then we don't really care about the array anymore, so we can just take the struct out straight into there. And that is how we set up the expiry. The expiry time length from this point on is probably useless, but it's completely fine. It's going to be really lightweight on memory anyway, just sitting there doing nothing. But you very well might want to use it for your UI to say, this buff is permanent, isn't permanent, it expires on this date, it was originally set to this length. And you may be able to increase the buffs. That's might be something. After we've looped over all of the buffs and we've figured out which ones we need to add, we can now take the current relationship. So I'll just right click and do get relationship, which will get this function property here. I will do the exact same thing we've just done and do set members. I will tick the buffs. I will add in our pending buffs, connect it to it. I will pass it to the completed. And then I will simply return our new struct out, which is our updated relationship. So we'll pass the relationship into it, handle all the buffs, setting the expiry date, and then returning it. However, we don't actually want to return it just yet, so I'm going to move that all the way down. This part up here handles adding. We now need to handle removal. Adding buffs. And you'll notice we don't actually directly set this on the struct, the relationship struct directly. Two reasons for that. One, it makes it far easier for us to add to a little array. Down here, remove it on that array and then apply it once. And secondly, up here, we're just dealing with in-memory variables at the moment. It's really quick because we create a variable, store it in memory, run, fine. If we keep adding it to this big relationship struct here over and over and over again for each individual one, that's got to set it a ton of times. Whereas here, it's just adding it once, one bulk update, boom, done. Less chance for it to interfere. So now let's move on to removing our buffs. Whilst we're adding all the buffs up here, and we're seeing if we need to actually apply them, so I'm going to make a bit of space and just move a ton of this across a little bit so we can... And what we're going to do is basically not add this buff at all if we're removing it. There's no point even processing. So I'm going to add a branch up here and connect the false to the branch up there. And we will get our buffs to remove, enum array, and we will say, does this contain the buff type here? And we'll connect it to there. If it's true, we're just going to completely ignore it. We don't need to process that buff. There's no need for it. We've got a special armor. That means we don't need it. Perfectly fine. If it's false, however, it means we do need to process it so it can move on to this branch and see is it permanent or is it an expired one. And I'll add it to our buffs pending array. Perfect. After the completed, down here, we need to actually check the current buffs the relationship has, remove anything from it, and then finally add it back on to the relationship. So I'm going to get the relationship from the variable, from the function input parameter, and I'll break it and get our current buffs. I'll do a for each. And then we're basically going to do the same thing, but without any of the calculations, because we've already done all of that. So I'm going to get the buffs to remove, branch off of it, break it, paste it down here. So I'm going to get all of this stuff up here with the break, the buffs to remove that contains in the branch, paste it down here, and connect it up. And then we've got pretty much the same thing, where we're saying, need to be removed, yes, don't do anything false. Then we're just going to come and add the struct to the buffs pending, just like that. And we can connect this down here, across to there, like so. We can collapse this, we can even hide the variables within it. We'll now remove existing buffs. And then on the completed of this one, we've added all the buffs that we know we can do, and we've calculated all the new ones. We've removed any existing buffs we don't need to add, and then we've done it. So this function is also now complete. So we do have a little variable here, a little oversight, where we're modifying the existing relationship. It doesn't like that because we've passed it in, but that's completely okay. Because what we'll do instead is, instead of setting it like that, we'll just straight return the buffs instead. And then we'll set it on the function when we call it. So all we're going to do is output the final buffs that we know we want to use. And we're going to export it from this function with a return. And then back in our update relationship, we've updated the relationship here. We can move all this across a little bit. And just before here, where we go and update it, we can drag in our update relationship buffs, where we pass in the current relationship. We can get the buffs to add and the buffs to remove, which are function parameters from the beginning of this. And we can come here and we'll say update relationship buffs, and that will return the final buffs that we need to use. And then on the set members here, we can just add the buffs into it, and we can add it to there. So I'll just come and promote this to a variable called updated buffs, connect it to there, and connect it back over to the set. We'll make a little bit of wiggle room and add our updated buffs into the set here, where it can officially set it. We'll hit compile. All the errors have disappeared. We're looking good. So now, ladies and gentlemen, we've added a system where we can add the buffs into it. Let's go and try it and see how it works. Once we've tested it, we're going to move on to the expiring part, where we loop over, remove any expired buffs. So how do we test it? I'm going to come and click my relationships, and you can see if I open it up, I've got the Knight Merchant. His value is 0 because we don't have any relationship with him at the moment. If I come and add a buff here, we will say we are a blood relative, so we instantly get a plus 50. It's a permanent one, so we don't need to worry about any expiry stuff. Fun fact, if you were in C++, we can actually hide variables based on a boolean. Unfortunately, Epic doesn't expose this to Blueprint. Sucks a little bit, but it's not a big issue. And it's called metadata in C++ if you needed to know. But you can literally hide entire variables just by saying only show if this is true. Let's give this a try then. He should have a relationship of 0 with us, but the with buff should now be 50. So he should have a relationship of 50 now. But you'll see if we run it, it says we've still got a 0 relationship, even on the buffs. Why is that? And the reason is, when we first come in, the update relationship is the only thing that calculates the buffs. It doesn't do it automatically on game load because we don't need it to. However, we are going to fix that in a moment when we add the timer in, because one of the things the timer will do is remove any buffs and then recalculate everybody's value, but we will tell it to run that function on game load to recalculate everybody's value anyway. So just for that little oversight, we'll ignore it for the moment. So you'll see if we print out the current value, it says we've got 0 and 0, but that's okay, we've just discussed that. If I just set the relationship value to 10, you can see it now says we have 60 because we are family. So he's happy with that, which is great. You may notice it will probably turn around and say you've got 0. Just make sure you connect that up to there like so. On the update relationship, we return the updated relationship. You also need to return the final value. That's just... So if we come and add in another, and we will say he's family, but we attacked him. So he's a bit cheesed off at us. So we can do minus 25. I won't set this to permanent, and I'll say it will expire in 1 day. And we'll hit compile and save. We'll jump back into the game. You'll see by default it'll say 0, and then it won't now say 60 like it did last time because it's going to add the family value onto the 10 because we're setting it to 10, but then it's going to remove the 25 because we attacked him. So you can see we're at 35, which is because he's family, it means it's good. It does, however, mean if we go to minus 100, so he really hates us, he will never truly hate us because he's family, it's removed a chunk off of it. How cool is that, ladies and gentlemen? So it's really flexible to add the buff system, so you can really change your world and make it listen to your action. So now for the final part, and I do apologise this video is getting a bit long, but it's a big system, this buff one, and I don't feel right splitting it into 2 videos anyway. Let's handle the expired relationship buffs. So the ones that have gone over its past, it needs to remove it from the system so he likes you again. So I'm going to straight away come and create a function called calculate relationship buffs, and all this is going to do is loop over every single buff on a frequency, so we'll set it to like 10 seconds, and it will remove any buffs that are expired. So the first thing I'm going to do is come and get the ultra dynamic sky date time again, just like we did last time. Oh yeah, there's a little function you can use to get it straight away, or you can get ultra dynamic sky and get it that way. They do the same thing. But I'm going to store this in a local variable called current date time. Now, the reason I'm saying this is even though your system should be quick enough to loop over every single buff, calculate them against the same time, it might not. And it might be a few seconds out either way, which is probably not going to be a problem. But also, this is more optimal because if you open get date time, it gets ultra dynamic sky and gets the date time. But get ultra dynamic sky runs a get all actors of class, meaning it's searching every actor in your world. If you run this on every single relationship, 100 times it's going to be getting all the actors, calculating the date time, getting all the actors, calculating all the date time. That's a big optimization flaw. So instead, if we do it once and save it, we can just use the same time over and over again. It doesn't matter if we're calculating one relationship or a million. They will all be calculated against the exact millisecond. It's a huge performance gain because we're not searching all the world for ultra dynamic sky every single time. Next, I'm going to get all of our relationships and I'm going to loop over them all. And this is going to gradually get bigger throughout your game. But unless your game's going to be handling millions of relationships, you'll be okay. It's going to be very, very quick to run this function. I'll promote the relationships to a local variable called current relationship. So this can be used when we're trying to modify and remove the buffs. And then I'm going to break on this and we're going to loop over all of the buffs that this relationship. So for each person, get me each of the buffs. I'll promote this buff to a local variable called current, and I'll break on this. And now we can check if it's actually expired. So the first thing is, we don't need to check if it's a permanent one. It's not got an expiry date. We can just count that as we can keep using it. So I'm going to add a new variable, updated buffs. And I'll make sure this is an array of S relationship buff types. So it's already done it. I'll add this in and just do add. Just like we did on the function before, where we take the current buff and we add it to the array of buffs that we're allowed to use. However, if it's false, then that means we need to check if it's expired. So I'm going to get the expiry date, and I'm going to do less than or equal to date time. I'll add a branch and connect it up. What we're checking it against will be our current date time. So is the expiry date less than whatever the current time is? So that was 20 minutes ago. This current date time is 20 minutes after. So true, we can remove it from the system, meaning we don't add it. False, we're still in debt, so we will add it like so. This one, we'll just add a comment saying auto add perma buffs, and this one down here will be expiry buff, and that will remove any buffs that we don't need because their time has expired. On the completed, we now have a built-up array of the buffs that we need to use. So I'm going to get our current relationship variable. I will do set members on it and set our buffs. I will drag in the updated buffs and connect it to it. However, because we've now got the updated buffs, we need to recalculate this relationship's value. And now with this struct, we could technically call our update relationship function, but that's going to be doing a lot of heavy processing of finding the right character and sorting it out. We already have all of that right here. So instead what we're going to do is simply call calculate relationship value. We will pass in the updated buffs to it, like so. So we'll be reusing it twice. We will also get the current relationship, and we will break it and get its current base value, because we don't want the final value, because this will calculate the final value for us. And then on the set members, we can add the final value, and we can retally it based on the buffs on our system. And then now you're thinking we must need to set this. That is true. So I'm going to come back up to our characters here. I'll make some space for us. And I will promote the array index to a variable called current relationship. I'll connect the loop body to it and this onto there. And then it means down here, we can get the relationships and we can do set array element. We can pass in the new structure to it and we can pass in our current relationship index. Now you might be thinking, why don't we just store this as one big array and update it just like we're doing with the buffs? And the reason is we can actually do it a bit more optimally, and we can actually do a little optimization tip to this, so we're not resetting the entire relationship value if we don't need to. By up here, if we just had a local variable saying buffs have changed, the buffs have changed, I'll set this to a single boolean, and all I'm going to do is set this on true here. That's all I'm going to do. And what this means is down here, if the boolean buffs have changed is true, it means that we've basically removed the buff. So we can come in and we can recalculate and reset the relationship value here. So I'll wrap this in a comment saying have buffs changed, recalc. And the only reason we need to do it there is because we're already looping through the character's buffs. If we're just adding the auto permanent buffs, we already know they've got them. If we're just checking if they've expired and they haven't, we already know they've got them. The only way we know if the buffs have changed is if we're actively removing them. And then we can tell it to recalc. Meaning if we come through and none of them have expired, and they're all still permanent, then this doesn't need to be recalculated because it's already set. It's a nice little optimization technique. The only other thing you will have to do is just before we start looping through all the buffs, just make sure you reset the buffs have changed. Otherwise it will break on the next one. So reset it to false just before you loop over the buffs. And then it can come in here with a fresh slate, check everything, and then it won't set every single relationship, only the ones which have changed, which is exactly what we want. If we do recalculate the buffs, the only other thing we need to do is make sure that we actually empty the updated buffs. Otherwise the first one will add to it, the second one will add to that as well, and it will keep. So where we set the buffs have changed, just also clear the updated buffs, because we don't want that interfering with multiple NPCs. And with that, if we jump back to our event graph now, and I'll add a new graph called relationships graph, just to keep it clean. I'll right click and do event init, which is how you do begin play on the game instance. And I will simply call calculate relationship buffs, which is our function, which is going to solve the bug earlier where he didn't have one at the start. And then I will also come and set a timer by function name. I will set the function name to be our calculate relationship buffs. The time, you can set this to however many times you want it to check on a loop. So I'll also tick loop. I'm going to set mine to 10 seconds for demo purposes so we can quickly see it on debug. In the main game, I'll probably set it to something like every minute or something. I believe in Ultra Dynamic Sky, a minute in real world lasts 1 hour in game, I think. So I don't need to be checking 30 minutes or something like that, because that's not my game. I'm just going to set it to 100. That's 1 hour. So I'll set it every minute. Set yours to whatever you think. With how well we've tried to optimize it, you could even get away with every second. Just know the more things you run rapidly, the more hitches you could potentially have later down the line. So for me, I'll set it to 10 seconds for demo purposes. I'm also going to come and tick max once per frame. Now this really shouldn't be an issue for us, but what this does is if our function takes longer than the time to run, this timer is going to tell it to rerun it. And we don't want that, because our function should not be taking 10 seconds, even 60 seconds. But if you set yours to run every 0.1 second, and the function takes that long to update it, this could make it go back in and recall the function again, which might be an issue. We don't want that, so I'm just ticking max once per frame to say if it's already running, don't run it again. Shouldn't be an issue, but that's what we've got. What we're going to do is back on our init, instead of calling calculate relationship buffs, because we've tried to optimize it, which is fine, what we're actually going to do is just get all of the relationships, loop over them when we start the game, and we're going to call update relationship, like so. The timer will come afterwards. We'll break on the array element here, and we'll pass in both characters. We don't need to worry about anything else because the system will take care of itself. And that will now run through, calculate all of the relationship's expiry dates on begin play. And then on completed, we can now set our timer. The final thing we need to solve, partly due to game order, is when event init runs, ultra dynamic sky isn't in the system. It isn't in the world at the moment because this runs first. So we need to wait for ultra dynamic sky to exist before we can do this. And unfortunately, the game instance doesn't have any way telling us when the world's loaded. You can in C++, you can't here. We could simply add a delay or a timer, but the problem is, what if your world isn't loaded in time? Then it's going to be miscalculating all the expiry dates for these, and we don't want that. And instead, I'm going to come to my BPI game instance and add a new function called onWorldLoaded. That's all it's going to be. Compile and save. Back on our game instance, I will add the onWorldLoaded into our relationships graph and just tell it when the world's loaded, now do all of this. But we need to tell this function to run when the game is officially loaded. So what I'm going to do is come back to my game and I'm going to find my game's game mode. So in my case, I'm using the ALS game mode here. You've probably got your own custom one. Just use that. And then what I'm going to do is on event begin play here, this is when the world has loaded. So I can now do get game instance and I can tell it, hey, the world has now loaded. Run all your calculations. So remember, this key bit here is how the interface works. You need this bit. If you don't tell it here, it won't work. Equally, you can kind of put this anywhere, these two, as long as it's on a event begin play. Because of the way Unreal loads the world, the game instance is loaded first. So we'll wrap this in a comment, update starting buffs, and start time. And finally, the last thing we've got to do is we actually do need to make it recalculate the relationship's expiry dates, because the update relationship will only update the buffs for the new buffs we're adding. It won't update the existing expiry dates because we already assume we've already done it. So to make this easier, what I'm going to do is actually just duplicate update relationship buffs and call it game load update relationship buffs. And then what I'm going to do is come in and disconnect the buffs to add. I'm going to delete all of the removal one because we don't need it, and I'll delete the return because we don't need that either. Then on the game load, I will delete the two variables for the buffs. I will change the relationship to an array. Then I'm going to come and loop over the relationships. I'll promote the current relationship to a local variable called current relationship. I'll connect it up. I'll connect across to the buffs and I'll break on the current relationship so we can loop over all of the buffs, like so. Then we'll loop over all the buffs. We'll ignore the ones to remove because we don't need to worry about that at all. We just want to run the expiry parts. So for anything that's permanent, it will add it to the buffs array. Anything that needs calculating, it will calculate. On the completed of running over all the buffs, we can get the current relationship. We can set its members. And we want to set the buffs. We can drag that to the completed. We can set the buffs pending into it. And then we'll come back up here. We'll promote the array index to a local variable called current relationship and connect that up. Just like we've done before, we can now get the relationships. We can set the array element, connect the exec pin, the struct, and the current index. Size to fit, so if it changes size for whatever reason, but it shouldn't do. And then finally, we just want to reset buffs pending so it doesn't stack on top of multiple NPCs. So what this is going to come and do is come in only once. This function will only ever run once in the game because we don't need it to run multiple times, but it's nice to have if we do. It will store the current relationship, loop over the buffs, calculate every single buff's expiry time, and then it will reset it on the relationship. And because we've cleared it and because we've reset buffs expiries, we also need to recalculate their relationship. So I'm going to come and enable the final value so we can calculate the buffs. I will use our calculate relationship value. We will pass in the current relationship value so it knows what to base it on. And we will pass in the buffs pending so we have the updated buffs. That will give us the final value, which we can now pass in to there like so. You may be safer to clamp it just like we did earlier. So we'll do -100, -100. And as I say, this will only run once. Back on our relationships graph, we can remove this update relationship and the break, we don't need it. Add our new fancy game update relationships, connect it up. The timer can run afterwards to start calculating it. If we try it now, you will actually notice it's still not working. And this is a little bit of a mathematical oversight I've had, but it's a really easy fix. But you'll see we have a buff of 25 and we've told it to expire in a day. So if I go to midnight in UDS, it goes to the next day. It still should be there, which is correct. But if I set it to 1000 when UDS starts at 9:40, it should now officially be gone, even if we wait the 10 seconds for the timer. But you'll notice it won't disappear. And the reason is, on the mathematical part of us calculating the expiry date, we're taking on UDS's hours, essentially, and then treating it as minutes. So it's actually recalculating out to be nearly 40 hours of in-game time, which is not what we need at all. So instead, what we're going to do is still treat this as UDS's hours, if you wish, but we're going to divide it by the UDS hours of 2,400, because that's what it is. And then we're going to multiply it by real-world minutes in a day of 1,440. And then we're going to use that as minutes instead. So what this is actually going to do is take our time, and I've set it to 2,400. That means a full day. It will divide that by 2,400, give us 1. That will multiply to 1,440 and basically say from minutes, give us a full day and add that onto the date time, so the expiry date. Equally, if I set this to 1,000, so it lasts for 1,000 hours of UDS time, so I think 10 hours, divide that by that, add it by that, it will basically come out to 10 hours worth of minutes. I do try to avoid mistakes in the middle of videos. This one was hard to really patch up on, I apologise. But copy all of that. Make sure you add it to your game load update relationship too. So just paste it in here, because otherwise it won't calculate it from the start. And now, ladies and gentlemen, for the final time. If we play it now and check the relationship, we're at 25 because he's family, but we stole from him. If I advance to midnight, the time will pass. I can check it. We are still on 25, which is correct because he's still mad at us. And because UDS starts at 9:40, if I advance the time to 10 o'clock and let the timer run, so every 10 seconds you can see it's just ran, we are now at 50 because that buff has successfully expired. How cool is that, ladies and gentlemen? A fully working buff system in our relationship. We can even come in and say stole from him and attacked from him -50. So when it all calculates, he will hate us. But this will only last half a day because he doesn't really mind too much. Well, he does, but if we try it now, you can see he hates us. He's not going to talk to us. He's not going to do anything because he's really annoyed with us. If I wait till midnight, he will now successfully like us again because we've not stolen from him. But he's not a major fan of us, as you can see. He's okay with us. He's got over it. If I wait until a little bit longer, where the expiry date has now run, you can see when the timer runs, we've gone back up to 50 because he's forgotten that we stole him and he's got over the fact we've attacked him. The buff system, ladies and gentlemen. I know this video was long, but it was absolutely worth it because we're going to start having some real fun with this. We now have a way to really tally it all up. In the next video, we're going to look at actually adding buffs dynamically to NPCs and relationships. We've already got our update relationship to add it in here, but we're going to go and start adding some gameplay elements. So maybe we talk to him and we say something wrong, he gets a buff that is a bit annoyed. Or we make a quest, we do it wrong, we fail, he gets annoyed, otherwise he likes us. We'll start building little choices like that in. After that, we will start looking at the dating part of it. If you get so far, we can take them on dates, hang out, stuff like that. So thank you for watching, ladies and gentlemen. I hope this helped. It's a big system, but it's absolutely worth it. If you've got any issues, please let me know down in the comments, or reach out to me on Discord and I'm sure we can help. Thanks for watching. My name is Decryption and I will see you next time.